Hello everyone, my name is Asif Khan and I am the Director of Innovation and Technology at tkxel. And today we have John with us. So John, thank you very much for making the time and connecting with us today about better tech. So today we will be primarily discussing analytics and robotics. So John, why don't you go ahead and give us a brief intro about yourself, who you are, what you do, what you have been up to, and talk about some of your experiences.
Yeah, great. Thank you for the invite. I'm John Crupi, and I've been in the industry over 20 years, focusing on Internet of Things, enterprise software, analytics, distributed computing, robotics, and AL and machine learning. And really, the goal has been my goal has been always how to connect things, a lot of things, and get real-time data. I've always been about real-time data. But throughout the years, as time has gone on in Industry 4.0 and different types of machines and assets and IoT have been moving more and more into the analytics world, I've been taking essentially what I've learned in distributed enterprise computing and applied that to Internet of Things, industrial Internet of Things, robotics.
Oh, okay. Thank you very much, John, for the quick intro. So John, as we discuss, robotics, by robotics, a lot of things basically pop up into our head, maybe a Honda robot or the Prince of Qatar basically having a robot as a security guard behind him, right? So these are all the fancy things that we have been seeing around as well as in the movies, right?
Yeah.
And analytics is sort of when we talk about like a bunch of graphs or charts, various sort of dashboard and all these things. So how do you think that these two relate? So for example, how robotics analytics can be merged or how they are related in a general world?
Yeah, so I'll start with robotics. So you could think of robotics as, you're right, a robot could be anything from an industrial machine arm that's building cars to new generation of surveillance robots to even drones people are calling robots. Basically anything that moves or has mechanical parts that tries to do some sort of action, I would say forms in the world of robotics. This has been really progressing a lot in the last, I would say 5 years. Traditionally, maybe over the last 20 years, it's been more industrial robots. And I also think that we should start talking about autonomous robots, robots that actually can make decisions about things. And so robots are really made up of a bunch of sensors, right? They may have everything from GPS to LiDAR to sonar to cameras to maneuver around things to a bunch of environmental sensors, gas, water sensors, things that measure movements. So there's no really one term about what a robot is, but you could see that there's different forms of robots that are starting to come out. And I think really sensors in terms of robots are really things that read data in. Okay, so when you're looking at LiDAR, it's doing laser and it's looking for points around you. When you're doing gas sensors or nutrient sensors, it's taking readings. Well, this basically is raw data. So robot systems today are really good at accepting raw data. They're really good at doing things with LiDAR and navigation, but there really hasn't been a lot done with other types of information that could tell you. So if you have an environmental robot and that's going around and it's in the water and it's looking for harmful algal blooms or things like that, you may just be getting readings and showing raw data, squiggly lines. So analytics is really about how do we take this information and put it into insight? How do we take all these sensors that are being added to robotics and how do we give information back to the consumer? And this is really how you talk about merging analytics and robotics. It's really the analysis of the data that is not just sensing and providing raw data, but it's also looking at what's data telling about what's happening now, and also telling us what happened in the past and giving us temporal analytics and spatial analytics to give us more deep insight. It's not just looking at a point in time, it's looking at things over time.
Yeah, that's helpful information. So these days we are also like talking about the industrial revolution and all these things, that industry 4.0 is going to be something in the future, and there's going to be a lot of new and emerging technology that, as a part of that industry, right? So
Yep.
how do you think robotics and its associated data analytics sort of streams and practices can be helpful for the next industrial revolution that we are calling Industry 4.0? So how do you think both two would converge, and what benefits that they are going to bring?
Yeah. So, so Industry 4.0 has been around for a little while, being talked about. It's, real, how do you take industrial equipment and essentially make it next generation where it's all connected, and it has analytics and all these things. I think first we have to think about what's taking so long, right? We've been talking about this for quite a while. And we've been hearing about data analytics and robotics and we know it's key for Industry 4.0. But a lot of people are saying what's taking so long. And Industry 4.0 is really, the next phase of industry or assets or industrial IoT. But it's a very mature field. So it's a lot of equipment that's been out there and assets for a very long time. So being able to take this secure environment and operate it securely and safely, and put it in a way where the organizations are comfortable with this is quite an undertaking, because a lot of these systems were never really designed to be connected to anything outside, right? If you have an industrial robot on a floor, it may be designed to just function there, never connected to the internet. So in order to start exchanging data and information and apply analytics to robotics, you have to have a whole bunch of things in place, because you're really going from the robot or the asset to the analytics to the cloud. And you need to have a cloud provider that's trusted. The two biggies are Amazon and Microsoft. So you can imagine like all that this has to happen if you're talking to an industrial 4.0 manufacturer, and they spent 100 years on their machines, their diesel engines, and now you want to add analytics and get it connected to the cloud. It's a whole different world, right? So
Absolutely.
It's no easy task for them to do that.
Right. So you just, briefly touched upon like it's like not an easy task. So easy tasks, as we say, will be having no challenges. But since this is not easy, it's going to have its own challenges, right? So what are some of the core or key challenges do you think are right now in place, merging analytics and robotics together? So what do you think are those?
I think risk and security are the two biggies, because you have to think about robots. So robots themselves move and can be very powerful and can do things, right? So it's maybe not just like an engine. Now an engine and a generator, those are significant too, in that all these things that you have, you may have robots on factory floors, on ships and power plants, data centers, the same thing you have with other industrial equipment. The thing about robots is that they move and they do things, so they could become quite dangerous. And there's been a lot of talk about, what if the robots take over and they do things. There's a lot of things that we could do for safety in that. But I think actually being able to have the analytics as part of the robots and built into the infrastructure it actually will help reduce risk and increase security, right? Because if these things are just sort of running and you don't know what they're doing and even potentially know what they're going to do, it gives you a less sense of control over these robots and what they're happening. So analytics is going to be a key core component for this. And it'll help mitigate the risk because you'll understand what they're doing, but also it'll give you more control over what the robots are doing. But it's, these are industries that are trying to merge together. So the people who build robots, they may have a lot of analytics inside the robots, but they may not have anything built for how do you do analytics across robots, or how do you add new sensors and get it integrated. So you need architectures in order to do that. So there's challenges to all of this.
Right. So one further, a follow-up question could be that based on your experience right now, I mean, working with these companies, do you think that these companies who are into robotics are actually keeping up the pace, merging the robotics and analytics together? I mean, are they operating at the correct pace as they should be, or they are going slow, or they are going fast? I mean, how are they in line with the current trends?
I think that initially it's, how do we get robots in our environment? That's sort of the first step. Robots are, even though they've been around for many decades, like industrial robots on the factory floor, like I've said, there's a new generation of robots coming in. So if you look at Amazon and you look at other data centers, there's robots that are moving around and moving things. Robot surgeries and things will become more prevalent, and autonomous robots is going to really be the big differentiator in all this. When robots are able to move themselves and do these things, this will be where it's a whole new level of what has to happen. So I think that really the ability for us to understand really the bigger picture about, it's not just putting robots in place, but it's being able to put them in place and get information about the environment that's happening. Because what will happen is that the robots are going to get very sophisticated very fast. These robots have a whole bunch of built-in analytics for object recognition, for how they move around. But in terms of what they're doing and how they're working together, and also other sensors about their environment, that is a different part of a robot infrastructure. So just like anything else, if you have something like a robot that may be siloed, you want to build it into an architecture. So I think the key part of this is, how do you build robotics into an overall architecture that includes analytics in it?
Right. So, I mean, as I mentioned in the start, that with robots, when we talk about them, I mean, machines is something that comes to our mind naturally. But these days, there's a concept of software robots as well. So robots not just can be only hardware oriented, there are software robots as well. So do you think that the industry, if hardware robots are sort of too expensive to build, or takes a lot of time and infrastructure and everything, then maybe software-based robots, in order to automate various processes, can be incorporated into their processes to make things better, faster, and autonomous as well?
Yeah, so I mean, ultimately, physical robots at their core is software that's running, right? And it's trying to do things more efficiently, and it's trying to incorporate, different types of processes in there. Software-based robotics, the name is a little confusing, I think, to the robotics industry, but being able to sort of take the same principles, being able to automate the things that we typically do. So a robot will do things over and over and over again, and so will processes. So you can use the same sort of concepts and analytics and potential AI to automate processes that you would have more in the enterprise level than you would have in robotics. Now, can you actually completely replace physical robots with software robots? I guess it really depends on what you're trying to do.
Right.
If you're physically going to maneuver to a place, or you physically have to move things, or you're delivering things, think about robots, they're physical, they move. So I think it's more about the two coming together. This is no different than enterprise software and process software coming together. How did we get those two things together? The same thing is starting to happen, I think, with automating robotic software with physical robots.
Right. So what we are really talking about here is that, for example, companies which are making deliveries by drones, for example, right?
Right.
So those are robots all over, and
Yep.
they are doing some tasks which humans would have been done otherwise, right?
Yep.
Now, in this case, we really can't have a software robot per se. However, if we, for example, a human is doing some data entry work, sitting in a place, right? or maybe answering calls over the phone, or writing emails, or maybe providing customer support, right? Now, these are the things which are dealt at a software level in many enterprises, big call centers, BPOs, etc. So there, I believe we can have a place for software-based robots by incorporating robotic process automation, which is the software side of it, and that way it can be leveraged, right? What do you think?
Yeah. So when we build robots, we actually build simulators. So like ROS robot operating system has a huge. It's kind of the de facto standard of
Mm-hmm.
hardware robots, and it has a whole simulation environment in it. So what is simulation? Well, simulation is just data being passed back and forth. That if you're moving something on the screen, it's sending data about a robot arm moving. If it's sensing data from gases, you simulate that. Well, it's just data moving through. So a person doing email, doing different processes, what you're doing is kind of capturing the same events that that user is doing. And then you're applying that to analytics and AI, looking for patterns. Ultimately, analytics and AI are really looking for patterns and things. So the same way that we look for patterns in physical robots and the sensors that they have, you can look for patterns in software things that people do. And I think, it's a huge opportunity because people constantly do the same thing over and over and over again. And if you capture that as events and capture that and as a process, you can use the same sort of techniques to do analytics on processes.
Right. So these days, also, John, what we are experiencing is that many companies are innovating at a very fast pace. So people are constantly evolving. I mean, software companies, hardware companies, robotics, AI, machine learning, all of these innovations are happening, right?
Yep.
So many companies are keeping up the pace. Others are like just not following the trend. So what do you think will happen to those companies who are not innovating at a good pace? What's going to happen to them? Are they going to shut down, or they will just lose the momentum? What do you think?
I think, well, so I think that if you don't have analytics built into your product, you're going to struggle in the future, because I think what's happening is both on the hardware side and the software side, people are building analytics into their software. I mean, AI has really just changed everything. You could look at just with your iPhone or software you're doing, and even things like Grammarly that are
Mm-hmm.
using AI to correct your grammar. That's typically, we didn't have analytics in software. We would just write software, we'd make it work, and maybe if you try something a few times and it doesn't work, we give you some recommendation. But really, we don't help you. And so when we write
Mm-hmm.
software, really there's nothing well, now it's starting to happen this way, but there's really no analytics running to see how we can optimize you and how we can help you. So I think AI has really moved us to the next level, because writing analytics is hard. If you have to write analytics looking for patterns, you have to kind of write the code and you have to look for these patterns. AI, is built to recognize those patterns. So we can take the concept of AI and put that in the world of analytics and say, look, if we can model this stuff, we could optimize it. And now if we could, because on robotics, physical robots and software processes, it's all software underneath. So if we're running a robot and it has vision detection and it's running inferencing AI models to detect something, that's software that's doing it, right? It's the same camera, it's just software. If we're doing something when we're doing processes in our software underneath, and we've built models that show us how to optimize the flow, it's the same thing that's happening. So you're going to see a lot more things coming out that are called smarter,
Mm-hmm.
because they have AI and analytics in them. Even in the world of sensors, sensors are pretty, even though they're sophisticated, they're pretty dumb in terms of they tell you a reading and they get it out. When we talk about smart sensors, they're adding more processing to it and more software to it to give you more
Right.
information. People, the new generation, Gen X, Gen Z, they're going to be used to everything how they do it on their mobile phone, and they're not going to have the patience in using enterprise software or even robots that you have to tell it every little thing that it does, or it just doesn't understand what you're doing. So I think that it's got to move fast in order to survive. And companies that don't move fast, I think they're going to be at risk by being overcome by the new generation of companies coming out.
Right. So in the past, we have been talking quite a lot about IoT, right, in Internet of Things. So we had like Amazon Dash and all of these things out there, giving the consumers the power to, order or maybe manage their stuff easily, and with these connected devices. But now we are listening more about the IIoT, which is Industrial Internet of Things, right?
Right.
So how do you think that with IIoT, analytics and robotics and automation can really up the game for the industry?
Yeah. So industrial IoT is really, where I think we're going to see huge benefits coming from this. And when you talk about industrial IoT, it could be everything from robots to diesel engines to autonomous cars, autonomous trucks, anything with moving parts. It's sort of everything but the consumer side of things. And consumer side of things, they tend to be maybe smaller, easier, single purpose. But when you start connecting all of these things together, and that's the whole thing, is you really the whole idea of industrial IoT or any IoT is connecting things. In the industrial IoT world, it's a lot harder to connect things because of all the security and risks that are in place. These could be, if you're going to connect a car, an autonomous car to things, you have a risk. You have a security risk, you have a vulnerability risk. If you have an engine that's powering a power plant, there's a risk. And so I think, now that now we're getting much more confident about a secure end-to-end architecture. And by the way, the reason why this has taken so long is in order to do industrial IoT, you do need trusted cloud providers. So Amazon, Microsoft, Google, they've done a really good job at, getting industrial customers comfortable with the security they have in place, because industrial guys don't want to let their data out. So now that's in place, you could have an end-to-end architecture in place. Well, if you start connecting all these things and you start integrating all these things, you really just don't want raw data. This is not a big data problem where you just dump it to the cloud. This is where you really start doing edge processing and analytics as close to the device as possible. These autonomous cars have a data center in their trunk, right? They're doing all of it there. So you're going to see a lot more of the analytics moving closer to the industrial machines to do the analysis there. But you have to share this, and you have to look at the analytics not just across one, but across many. And I think this is where it's tricky, because the manufacturers of this equipment for industrial are not the same people that have experience doing distributed analytics or cloud architectures. So now they've built up a lot of this expertise, but it's a matter of getting the expertise in-house and also working with partners to get this, because you have to get a cohesive architecture in place. This isn't something like, you can't tack on security later, you can't tack on integration later. This has to be integration is actually a scary word for industrial IoT. So you replace that with, how do you get an architecture that has all of these parts as a part of the architecture versus going and bringing new things into the architecture. So I think that's going to be the key to moving forward.
Yeah, and I also think that analytics can be certainly very helpful in terms of the projections as well. So for example, if an industry has incorporated some robots, right, and they want to like really project that having those robots in place, what sort of revenue they can sort of increase, or what are their benefits of having robotics and in cutting the cost, right? So all of these things, maybe analytics can give them a clear picture, because just looking at the tabular data, it's not going to help anyone.
No.
Once we have like those charts, graphs, drill down reports, roll up summaries, and all those things in place, it can help the industry quite a lot. So, I mean, that's going to be the next thing. So, John, any closing thoughts? Any sort of thing that you'd like to say in the end?
Yeah, I think really real time is going to be a big player in this. So a lot of people will say, you know, they have analytics, they'll go to their machine, they'll put a flash drive in, they'll extract the
Mm-hmm.
log files, then they'll go send it to the big data team. I think that big data in the cloud has definitely done a lot of good for us, but the first phase or wave of this was people were thinking, well, let's just send all the data to the cloud, put it in there and analyze it. And it just became too much, right? And also it really was not designed towards real time. To really get this moving, I think we have to have the notion of real time to be able to watch things as they're happening, to take action and to do things. Also, what you said was right, is that traditionally it's been sort of break, fix, or preventative maintenance. You go in every 3 or 6 months or something breaks and you go and fix it. A lot of manufacturers don't have any idea how their customers are using their equipment. So a customer could be running it at 110% and the manufacturer may not know. But if the manufacturer says, okay, we're going to be connected, we're going to manage the performance of your equipment, and we're going to charge you a little more, but we're going to make sure that it performs right. We're going to automatically, you know, update the parts when it's needed, keep this thing running, and it'll be running better. And in the long run, it'll cost you less, but it's new revenue opportunities for companies because they could have, you know, real-time monitoring and performance maintenance. I think to get organizations to move away from just selling parts to selling performance and selling, you know, insurance about how things are going to run, I think that's going to be the next wave.
Absolutely. So, John, thank you very much for taking out the time today and speaking with us about the topic. And I appreciate you joining us. And it was like a really great help and a great topic for our
Great.
audience. Thank you very much.
Great. Thank you.